Here we're moving on to the topic of vectors. I'm only looking at vectors a little bit here. More importantly, we're looking at how vectors relate to matrices and how we can look at the dot product and cross product of a vector. It takes us on from a discussion in polar form where we know that a complex number can be represented with a modulus length. So a length value and an angle. So that's important with vectors here because vectors have a direction and a magnitude. So we can always plot vectors in terms of a direction and a magnitude. But what we also have is we have a 3D plot of vectors. So they can have a x, y and z coordinate. So previously we looked at 2D plots, now we're looking at a 3D. And there's not much difference, just you're given an extra point. And this becomes very important to us because of how it can relate then into a matrices calculation and also how we can then do the dot product and cross product with it using the little bit of matrices. So let's see what we're talking about here. So we can be given a problem and generally it's say a vector p, okay, will equal 4i plus 3j. It's 4i plus 3j minus 2k. And basically each one of them represents your plot on this here, in this 3D plot here. So we've got an I coordinate, which we then, I usually is represented by our x. J represents our y, j, and our k represents our z-axis. Okay, so that's the way we plot it. And also how we represent a vector. Usually you might see these little hats on them, just so people don't get confused with complex numbers and that we know it's a vector, maybe not any algebra or anything like that. So a couple of little theory parts there. And we can also have a vector or, okay, or equals 5i minus 2j plus 2k. That looks a wee bit like a j. So I, again we put our little hats on it just to signify that it's definitely a vector. First thing we're going to look at is something called a dot product. I'm going to try and do this in a different color. So the dot product is also called the scalar product. And what that does is when you multiply p with or, you will get out a scalar. Okay, so just a value, just a number, a scalar or a number. How we do that is we simply take the two I coordinates, we multiply them by each other, 2j, multiply them, and the 2k, we multiply them and add them all together. So we'll say p dot or, and just as a quick note, the dot is in the center, it's not a lower dot, so that signifies the dot product will be 4 times 5 plus 3 times minus 2, we call it minuses, plus minus 2 times 2. That will equal 20 minus 6 minus 4, which equals 20, minus 10, which equals 10. So that implies the dot product of p, the vector p, the dot product of the vector or will give you 10. So you just get out a number. When we go to look at the vector or the cross product, you'll see we'll come out with a vector. So that's a quick video, how the dot product works, and we'll introduce us to vectors, and we'll pick it up in the next video.